Hello everybody, we're back again. Today I'm going to go over the situation that's going on with Tropical Cyclone Rae in the South Pacific. Let's get straight into it. I'm going to begin by going over and going through the Tropical Cyclone code forecast issued by the Fiji Meteorological Service. Currently they have it analysed as a Category 2 Tropical Cyclone um, as a 14Z, which has, at the time of recording this, has been quite a long time ago. So we probably will get a new code sometime soon. But we'll use what we have at the moment. At the time, they had it analysed as a Category 2 tropical cyclone on the Australian scale. That's around high-end tropical storm, Category 1 on the standard American scale, Saffir-Simpson scale. Um, it's expected to strengthen further, likely into a hurricane 4 strength system, and probably a bit further than that as it heads southwards to the east of the Fiji group. Currently, what they have highlighted here on the on this graphic is that they've got a warning for gales within 24 hours here, and an alert for 48-hour gale forecast. That's along the forecast cone or the forecast track, I should say. And they have this warning area covering lots of isolated outer Fijian islands there to the east of the Fiji group, the main Fiji group there, and it's gonna be skimming past east of the main island there. I don't know what the island's called. That's my fault. I should have probably revised that before taking a look, but yeah, before that eastern main island, it's gonna skim past that with possible storm force winds on where Tavuni is, and gales likely extending to the eastern part of that island there as it passes. And as I said, intensification should be likely. It's ongoing right now. Let's actually go on to the current structure there. And I'll go over all that's one singular image. So initially, yesterday it began as a nice central burst, and it's gradually built itself a core structure, quite a loose one, quite a nice bandy one. As you can see, it's not very stable, not very rock solid. But it's much more of an eye now that it's appearing, and definitely a core that's in the process of being constructed. That short-lived banding eye did develop there. It's gone now, and now we've got pretty thick convective canopy. That could be a central dense overcast in the making. Definitely, as we saw, that loose core building. Now it's not really clear. There's definitely something ongoing still underneath the convective canopy, and the kind of covering of the eye is probably the evolving central dense overcast. Currently it's heading southwards, again as we saw, skimming the islands. It's moved south now with this island, and yeah, it's probably bringing some nice, pretty strong winds over to these islands, and it will continue to pass through. I was actually looking for some surface observations. Give me a minute. I was looking for some surface observations. How do I'm trying to get off this. Oh yeah, right. I was looking for some surface observations, as I was saying, on the Fiji Met website, and it takes too long to load. So we'll use what we have with Meteorologics. I'll have to select this again. I'm going to look for observations on here. And because what I want to typically do when a tropical cyclone hits land is to look at the data that we have. Look at the data that we have as we see. Nice. I think the centre's about to pass over this observation station here. And, you know, I want to see kind of what data we have. Better evaluate the current intensity of a system or any other information that we would like. We can use surface observations to best take a look and observe. Let me change the parameters here. So let's take a look at sea level pressure first to begin with. Nothing here. The data does seem to be hourly though. It just hasn't really processed through. Oh wow, that's a nice error that we have there. That's definitely not reliable. Um, that's wild. Anyway, yeah. So obviously, as the system approaches, we have this station have a. Sorry, I should probably write this a bit better. A decreasing pressure there as the system approaches, which is good, I guess, in this sense, for, you know, us trying to look for data. If we continue looking at this evolution here, we can see that this is the island that has the data. The center seems to have passed on it now. I think the 18Z data retrievals may be what will be the kind of data that we're looking for. We don't even have anything for 5Z, sorry, 17Z yet. We'll have to wait for all the data to pass through on this website to be able to actually take a look at the retrievals that we get. But we're going to have a pressure minimum probably observed there. Probably a secondary, or should I say, another pressure minimum on that island as the system moves further south. As we see here, it moves. It's moving down south, and it's likely that it might be a little bit off the center. It might be a little bit east, judging by the convective structure. But then again, would prefer to look at microwave imagery underneath to see where the actual center could be. But this could be relatively close to the center, and it'll be interesting what retrievals we get with regards to data on that station. So that's the current structure we got. Evolving, central dense overcast, building core underneath, and we're probably going to get to hurricane strength in about 6 to 12 hours, judging by the current structure. What's the current intensity? Well, okay, as I said, oh, we actually got onto the website, no way. Well, we've looked at the surface observation, so we don't need to look at this anymore. I wanted to look at the JTWC forecast code, and it also has the current intensity, or the intensity for 6E. So that's 12 hours ago. Don't look at that. They had it at 50 knots, assuming a nice, steady intensification trend. We're probably around 60. I mean, obviously, if we're looking at current intensity analysis, and I had to do the Dvorak technique and apply it here, I'd probably get somewhere in the range of 3.5 to 4.0, which would mean we're near hurricane force strength here, which is, as I said, I guess fits the intensification rate and is expected. That this was expected. This is meant to be happening, and I'll go over the intensification and why specifically this is happening and what could happen in the future. Let's get back to the code. I keep flip-flopping. I apologise for that. So, 65 knots was forecast for now. It's not too far off from what it could be now. As I said, it's expected. This intensification, it's expected. It's going as it should be. We've actually had the models around this kind of area and intensity for quite a while now, even before the system really consolidated into a tropical cyclone. So there was quite a good of agreement and good certainty that this was going to be happening. We're following the intensification trend. We're following the kind of evolution that we were expecting earlier. And yeah, short-term forecasting, the quick intensification that was forecast this morning has continued and actually has materialized. We're probably near that intensity now. I guess this is not actually what I would say. First of all, is that not looking at this forecast like at face value, because I know it's old, but it's the only thing we have, as I said, right? So, but we can use it to kind of look at, alright, we're going to get some intensification later on. Obviously, I'll go and do my personal analysis in a minute, looking at the model guidance and what we have available. But this is what the JTWC has. And they do still expect quite a bit of intensification to a high-end Category 1 on the Severe Simpson Hurricane Wind Scale, and that's probably that's solid Category 3 on the Australian scale. So that's what the Fiji Meteorological Service is basically forecasting, and as I said, there's decent agreement, both agencies agree. But I think we might get a bit of a higher intensity, and I've expected this now for, well, I've had this in mind for a couple of hours now. We're probably going to see something higher. As we see, this evolution is, for now, we're kind of following the expected trend of intensification. For typically what agencies like to do before peak intensity in their forecasts is they tend to kind of underestimate what could happen. And the intensification rate just abruptly kind of slows here, beginning at the 60 there. Instead of a 15 knot change in 12 hours, it decreases to a 10 knot change, a 5 knot change, and it peaks at 2418T. So that's not kind of what's expected. Now this is where I go into the model guidance, and I get to look at this in a bit more depth. Let's look at various variables here. This is the current forecast for 12Z, but this is where it would be now roughly. Passing over the eastern islands of the Fiji group, and as we can see, very broad. Oh, that is not what I was meant to do. Sorry, very broad upper level anticyclonic flow, very divergent, and very ideal to ventilate the system. Poor vortex over here, that's 92p, is going to get shit very badly because of the outflow, the very expansive anticyclonic outflow that comes out of Rae here. And we have steering by, let's change to blue here. Our steering is by this 500 millibar ridge there in the lower subtropics. That will be sending it further south as it's going right now. And that's the kind of pattern that we have in place at the moment. With a nice vortex over here as well, if that wasn't very clear enough. And that vortex, aka Rae, should be strengthening under the influence of this very anticyclonic environment, alongside very nice shear conditions. Let's look at the scuties that we have, vortex average, and yeah, looking at the environment here, it's not the best. When I meant nice, I meant it was conducive for intensification. I mean it's alright. I mean, let's take a look here. We have our wind profile mostly is southerly, on most levels, on most heights here. With regards to wind vector, with regards to the direction solely, it's not too bad. Very straight, southerly profile, which aligns with the movement vector somewhat for now. It aligns with the direction of the storm and where it's moving. So that's good to begin with. However, there is still some change in height with regards to wind speed. So there is some shear in this sounding, at least. This is for 0C, so that's from 6 hours from now. Now it's not much different. We can see very similar where the low level and mid level wind and the kind of holograph structure that we have here. Very similar. And what we have is the low level winds are quite strong. They go up to just over 20 knots. And then, yeah, the lower mid-level winds are also there, but they do start coming back in closer to the motion vector that we have for the storm. And then generally above I think 700, that roughly I'll take it as, roughly above 700 millibars there. Overall, not too bad. The steering is 12 knots, so with a vector of 15, 10, with vectors of less than 15 here, overall shouldn't be too impactful for the storm. If we're looking for the lower mid levels, down there. That might have some implications. Then they won't be drastically severe. They won't be so drastic. They won't be so big. Um, Particularly because of the anticyclonic outflow that I was previously discussing, which I'll go back to again. So as I said, right, we got that alright shear environment, relatively favourable. Then we got this very nice upper level anticyclonic flow, which yeah, I did bring up. And we can see, very, very nice. And this will continue. And it will potentially get enhanced, particularly when it comes to poleward flow, because of that upper trough coming in. So the ventilated flow does actually intensify because of its proximity to the trough there. And that is for tomorrow. That is for Monday. Monday is when the guidance really expects it to peak. If we look at the GFS here, and it's its minimum central pressure for Rae, we see it peak at 962 on 12Z Monday, with 972 and then 990 going on to Tuesday. And again, why does it peak on Monday? Well, the best of the outflow comes on Monday, and if we look at the soundings, which I cannot navigate through. Right, so I cannot navigate through the interface. If you look at the soundings that we have here, the box average soundings, we can see here that on Monday, February 24th, we have better alignment with the shear vector. We have our mid-level, or should I say our peak flow, our max flow at 20 knots for a short amount of time. Generally we have the low level and the mid-level flows quite aligned here. I can't draw that small. Where the storm vector is, storm motion vector. And generally all the flow is quite aligned. Direction and most of the flow is within the speed of the storm motion. It's generally favourable. It's generally alright. Even though, you know, we have here some stronger flow at 850 millibars. The overall flow, if we take a look at it on a large scale, broader scale really, it's fairly aligned here. Averaged out. It's not too bad. As I said, the outflow is also strongest. Obviously, as the upper trough comes in, that anticyclonic flow, particularly poleward, does strengthen, does intensify, and that allows for higher ventilation, which the storm definitely would need. Actually, interestingly, looking at the storm and focused on the vortex itself, we actually got lower pressure retrievals here on what the GFS forecasts here. Lower forecast minimum central pressure. So that's interesting. What we had on the global view was 962, but we only got 960 here. But nonetheless, nonetheless, we do have quite a decent seeding. There's not much time left, but we can definitely get this system to maybe a broad category 2 on the Saffir-Simpson hurricane scale, with potential for category 3. I won't rule that out. Sometimes these systems can intensify a bit more quickly than what the models show. That does happen in quite a lot of scenarios, particularly when the upper trough and nearby jet stream is involved. This environment doesn't seem too bad. I mean, this is only one model though, so we will take a look at others to make comparisons. It's never a good forecast. Never a good forecaster habit to have is to only look at one piece of model guidance. But there's also the need to have to interpret model guidance correctly. If we take a look at a bit of a broader view, we'll have a better idea. This is the ECMWF. Now, This is 6E, again, old, but this model does take quite a while to actually get its runs going. But nonetheless, we can see that that's not the most important part. The most important part is that what I wanted to address is that yes, it takes the intensity of Rae and does not put it up so much. It doesn't actually intensify Rae so much. If we look here, we can see that it's weak. It initializes at 6E as a 998 millibar system. So this is when it was actually quite weak at 6E. And obviously, it should be noted that the ECWF doesn't actually take in best track data for its initialization, while the GFS does. So GFS might have a bit more accurate results in the short term because the data when it gets assimilated for the model to run, it takes in the best track data for any tropical cyclones active. The ECWF doesn't done that, so the initialization pressure might be too low. It probably was at this time, but it was also a developing cyclone. It might have not been too far off the actual pressure at the time. Remember, that was 12 hours ago, so not too important. But nonetheless, we see here what's the most important part is that it only intensifies around 8-9 millibars. Well, sorry, should I say 6 millibars? 7 millibars only. 8. I didn't realise it got to 990, but the exact values don't matter. The point is that there's a very weak intensification trend compared to the GFS, and while we do need to look at multiple models, it's a reminder to know that we need to take into account biases, and what the ECMWF, the European suite, does is typically a weak bias where almost all the tropical cyclones are very weakly resolved, and their evolution is weakly resolved. It's not accurately depicted, and that's because the systems are too weak. I'm not sure what goes into this guidance going in to regularly being so weak, but what's always been a trend through the years, even with the recent upgrades, is that most of the evolutions forecast by the European suite are too weak. They're not particularly strong. So let's actually do a bit of a comparison here. The GFS at initializing at 981 deepens it a good 20 millibars in the space of almost 24 hours. So that's pretty good intensification. While the European suite, beginning at the initialization at 998 millibars at 6E, it only intensifies about 8 millibars, and that's in 30 hours. Sorry, 36 hours. Very slow intensification compared to the GFS, and I mean, I don't like to take the Canadian model, but yeah, even it is too weak, and these are usually 2 week forecasts are coming in from these models, and that usually happens. So never take into account these at face value, and not even a GFS at times. GFS can go crazy itself as well with the solutions it depicts out. And that's why it's best to not obviously do straight up reliance on the models, and particularly not in one model either. You've got to make sure that you know how to interpret them. But obviously, while we know that the ECMWF doesn't intensify it so much, we could still take a look at its environment that it depicts, and well, would you look at that? It has quite the environment, quite similar to what the GFS depicts. Obviously, that's no surprise, and there's good agreement in this system. Once again, we have this very nice upper anticyclonic regime, and particularly venting into the jet as it approaches. And that's good. That's a very favourable outflow regime for such limited intensification. What further might back up the need to increase the intensity forecast and not actually take the ECMWF solution at face value is obviously the soundings that might be coming up. And yeah, take a look here. Later on, this is when it obviously undergoes its interaction with the upper trough, with the deep layer trough even, and obviously we can see the flow is very strong. So this is when the environment becomes less favourable, and obviously the GFS also depicts that. So this isn't obviously too relevant. That is expected. But it's the near term, 24 hours, 30 hours or so, when the peak will be reached, that we look at the environment here. And would you look at that? I mean, it's not even entirely that unfavourable. Let's look at 24 hours. This is near peak, just before, or at least before when the GFS shows. I think this is the peak on the European suite, 30 hours. Again, a very similar kind of profile to what the GFS suggested. We got 20 knots, 25 knots, sorry, 22 knots-ish of the 850 millibar flow. That's the low-level flow. It's quite southerly strong. But then, obviously, when we get into mid-levels, it starts coming back down and aligns more with the motion vector of the storm. And then the upper-level winds aren't too detrimental, even if they ended up being even much worse. The main area of interest is the low-level, mid-level flow that we have, and again, it's not too bad. It's fairly alright. The profile is for the most part southerly, with a bit of a westerly flow in the upper levels. But given that any shear that comes out and about, particularly in our lower mid levels as well, near 700 millibars or above 700 millibars, below, and 850, where that shear is, generally there should be quite a big amount of outflow, as I've previously shown, that will offset that and should lead to some decent intensification nonetheless. Now, we've gone over the environment, and obviously we've seen that there's a bias in the ECMWF solutions, and the environment I've gone over is quite fair. That should allow for closer to a GFS solution with quite a nice intensification rate. Let's go back to a global view. I want to go over the track. So let's go closer to the to the trough ridge pattern and the steering influences that we have in place. So we're going to stay on the ECMWF and we'll go on to GFS sooner. And we'll also look at the ensembles that are in place, because we can't look, even though these are deterministic, more high resolution solutions, we're also going to take into account any of the wider spectrum. We're going to take a look at all the sorts of possibilities, and the ensembles are needed for that. Because there could be quite a bit of an ensemble range which could depict high uncertainty. Obviously, we know that's not the case here, as I've said many times. But nonetheless, still good to take a look at the ensemble. So I'll do that in a minute. But for now, we'll take a look at the deterministic solutions and also take a look in a bit more depth the evolution that we have. So as I said, as I've gone near the beginning, we have a very nice meridian here in the subtropics. We'll bring southerly flow, as we've gone over already, in the sounding suite. That was very evident in the sounding profile that we've got southerly flow. Then we'll take the vortex this way, and then as we got this trough that's coming along, or I'll draw it a bit better. As we got this trough coming along, it'll get picked up this way, or this way, as it goes that way, as the trough comes. It'll get attracted to that trough, and it gets picked up by it, and then it gets sent that way. And again, it's nothing too complex here. The GFS agrees. You can see here, same kind of solution, exactly what happens. I'll also take a look at the ECARFS, the AI European suite, and again, yeah, same kind of situation. This doesn't really surprise it, but yeah, I mean, it's also worth, as I said, take a look. While the European does have a bias, and because it's weak, particularly because the solutions are weak, they will be less influenced by the trough. But as I said, the kind of regime where we got a southerly flow, that it will get sent closer to the trough anyway, there's not much of a bias to worry about really with regards to track. So And the AIFS has also been quite good recently, with recent kind of observations. It's been relatively good with track forecasting. So that's kind of why I wanted to take a look into it. But yeah, now let's take a look at the ensemble. And again, very kind of good certainty. It's quite a tight system on the ensemble run, suggesting that any members within the region of the actual of the mean, quite tightly packed, and we can take a look at that, looking at the ensemble member being sea level pressure here. Fairly tight solutions here. When that interaction with the trough does happen, kind of split with regards to speed. That's after 48 hours from now. Fairly large envelope, but it's not too bad. It's nothing special. It's nothing that big. It's not that big. What's the word I'm looking for? Compared to the average, it's, relative to the average, it's not particularly too big of a track spread, and there's generally good agreement on the evolution. No significant uncertainties. Knowing the GFS solution, yeah, much tighter kind of area, though it does get kind of split during extratropical transition, but that's actually fairly normal, to be fair. We're still looking at the main kind of intensification phase, short-term evolution, 48 hours or so. Quite a tight spread. Okay, and then if we look there, we can see that there's a decent density of the members and their solutions. So as I said, that I just wanted to go over and just examine the kind of track certainty that we had. As I said, I just wanted to show that there is certainty, there is good confidence in it. And obviously there quite usually is in the short term, so it's nothing surprising. I did want to look through the charts. There's some charts. So obviously we got the upper level environment, which is very important. But obviously we got to take a look at the oceanic conditions as well. I don't want to discount them completely. This was at 0C. No, this is 12Z actually. What am I on about? It just looked like 12Z for me, 0C for me for who knows why. But yeah, we got the 12Z positioning here. We'll probably get the 18Z positioning shortly because it's very close to it. Right now, well, we're past it. We're probably going to get the estimate soon from the JTWC via the ATCF. But we'll look at what we have right now. And again, it wouldn't be much different anyway because it's not moving too far south too quickly. The overall area that it's in has a decent amount of. Oh my god! Stop doing that. I've already got it. Big chunk of. I should probably choose a better colour for this. Stop doing this. Oh my god, please stop it. Right. We have very nice area, very nice pool of 30-degree waters. Very conducive for any intensification. Obviously, it's deep in the South Pacific, peak Southern Hemisphere season, so it's not too surprising. And then when the peak should happen at around 20 degrees south, we're probably looking at about 29 degrees ish, maybe going slightly down to 27 at the end of the peak. And this is a 29 degrees, is it? I'm sorry, I can't see the color bar because my thing is blocking the way. Yeah, it's 29 degrees. So 29 degrees, very nice warm pool, 29 degrees here. With decreasing to 28, 27 in the latter part of the peak, which will be good for maintaining that peak and getting it to the peak in the first place. Nothing to worry about with regards to sea surface temperatures. So overall environment and analysis, it's very time limited. It's currently undergoing pretty big intensification here. Nothing too special, nothing too explosive, but it's fairly significant. There is quite a bit of decent intensification going on with regards to its central dense overcast development, and it probably is strengthening. If anything, it's probably a Category 1 tropical cyclone on the severe Simpson hurricane wind scale right now as I speak. But yeah, the overall, what I'm trying to say is, there is decent intensification going on. It won't be stopping imminently, but it doesn't have much time left. The environment is generally quite favourable, and if it had a bit more time, it could get to a bit of a higher intensity. But right now, what I would expect, pretty solid Category 2, I would say, in my opinion. When the new round of forecast cones by the Fiji Meteorological Service and the JTWC, when they come out, we're probably going to have a peak intensity increase, given the environment and the intensification trends. And yeah, the environment is favourable, but we do not have quite a lot of time left, and that's what it will be. That's what Rae will be limited by tomorrow. I hope you guys enjoyed and found this interesting, and are now aware of what's going on with Tropical Cyclone Rae. Actually, I should probably take a look at one more thing. Yes, I wanted to take a look at the microwave structure before I finish. I'm not very organised today, I apologise for that. Take a look at the latest image. That is way too old. But if you can tell here, we've got a nice curved band wrapping here, and banding like wrapping in. Kind of probably evident signs of a nice banding core structure developing. And I think there was more recent microwave which actually did back them up. Or there was low level to back them up, I think. Hold on, what's the archive looking like? Yes, this new image. Yeah, so evident here. Nice banding, wrapping around. Not solid, but that's how banding eyes typically start. And yeah, banding core structure likely to solidify within the next few hours going into tomorrow, as the environment remains favourable and as time progresses. There was also low level microwave view. It's been a satellite. Yeah, so looking here, it's very elongated structure. I think that was a higher quality microwave. Yeah, this is from SSMIS. Elongated, but there's evident low level core structure there, as that banding wraps around and forms an eye-like feature on microwave. This is a better view. Evident core structure and low levels there. That does show that there is some consolidation occurring. And yeah, that's kind of what we have. And then that's obviously above. That's the hood. That's the convective canopy here. And the microwave under the hood evolution doesn't surprise me in any way with what we've seen on microwave. We'll have to take a look at this during the next couple of hours and over the next day or so. Take a look at the evolution and see how that intensification progresses. What could go wrong here? Potentially excessive amount of banding, energy being used, could deprive the inner core of energy. I mean, what we're seeing here, typically when you've got high, very favourable thermodynamics, you can have too much banding, too much energy being used. The substance is imposed on the inner core, especially in the north, where there's intense southerly flow and convergence on the northern quadrants. If you look there, very intense convection there and very intense banding. We'll see if any of that consolidates on the inner core. But if any outer banding is around, that could cause some problems. And we'll also see if that outflow, if the very anticyclonic outflow regime, we'll see if that actually offsets any of the present shear, which to some extent is around. We'll see how that goes, and we'll also see how that sloppy, broad structure evolves, because there's going to be a lot more energy and time needed for that to consolidate. But the environment does remain favourable. We'll see what it does in the next day, while it has that time before deep layer vertical wind shear increases as it does that trough interaction, and before it goes for good. So, thank you all for watching. Hope you guys have the information here that's needed on the in-depth meteorological perspective of Tropical Cyclone Rae. I'll have more content coming out soon with regards to other tropical systems and any other things that need to be having a video on. and hopefully I should have more content coming in general because I haven't really been uploading for a while. Thanks for watching, guys. I'll see you guys in a bit.